Deliver with scholarly warmth, pace, measured and thoughtful, tone, reverent and awestruck. Last video, we followed a single photon and watched Richard Feynman rebuild how light travels across the universe. Today, we are going to do the same thing with a much stranger question. Why is absolutely everything, from the coffee in your cup to a galaxy 13 billion light-years away, spinning? Cornell University, 1946. Feynman is burned out from the Manhattan Project. He is thinking about quitting science. A student tosses a plate across the room. On the side, the Cornell medallion. And as the plate flies, it wobbles. Feynman notices the wobble rotates exactly twice as fast as the spin. 2 to 1. Always. He scribbles the math on a napkin. That wobbling plate became the path to his Nobel Prize. Because spin, it turns out, is how the universe writes its memory. The universe remembers, and in the next 35 minutes, I am going to show you where. Earth, once every 24 hours. Earth around the sun, once a year. The sun around our galaxy, once every 200 million years. Hurricanes, tornadoes, the water in your drain, a neutron star spinning hundreds of times a second, a black hole dragging space-time itself. Same law, same memory, different volumes. Here is the challenge. By minute 25 of this video, you will understand why all of that spins. And then I am going to show you the 5% that does not. The piece that is quietly pointing physics toward dark matter. 3 acts. 1 plate. 1 galaxy. 1 ghost. Let us see what Feynman saw. Tonight, if you walk outside and look up, you will see the simplest spinning thing in the sky. The moon. And the moon has a problem. Nobody ever told you about it in school. But once you see it, you cannot unsee it. The moon is moving sideways, right now, at a little over 2,000 miles an hour. Gravity is constantly pulling it toward Earth. So here is the question nobody asks out loud. Why does it not fly off into space? And why does it not crash into us? Because those are the only 2 things that should be able to happen. And somehow, neither of them does. For 4.5 billion years. Here is what is actually happening. The moon wants to go straight. Newton's first law. A thing in motion keeps moving in a straight line forever, unless something tugs on it. But something is tugging on it. Earth's gravity, pulling it down, constantly, every single second. And when you add those 2 together, the straight line and the downward pull, you do not get a crash. You do not get an escape. You get a curve, a continuous curve, bending back on itself, forever. So here is the cleanest definition of an orbit you will ever hear. An orbit is just continuous falling that never lands. The moon is falling toward Earth every second. It has been for 4.5 billion years. It just keeps missing. And the same thing is true for us. Right now, you and I are moving sideways through space at 67,000 miles an hour. Gravity is pulling us toward the sun. We are falling toward it, this very second. We just keep missing. So that is how things stay in orbit once they are already moving. But where did the moving come from in the first place? To answer that, we have to rewind. Not a little. All the way back. 13.8 billion years. Rewind the universe. Past the stars. Past the planets. past galaxies even existing. Keep going. Keep going. 13.8 billion years ago, everything you can see was packed into a point smaller than an atom. Hotter than anything that has ever existed since. And then, it expanded. That is the Big Bang. But here is the part nobody ever fills in for you. What the Big Bang actually handed the universe in its first second was a mess. The Big Bang did not hand out neat little orbits. It did not hand out planets already in their lanes. It handed out chaos. Particles. Hydrogen. Helium. Enormous clouds of gas stretching across light years of empty space. And those clouds were not sitting still. They were shivering. Drifting. Shock waves were rippling through them. Tiny temperature differences were tugging on them from every direction. Billions of little nudges pulling in random directions. No plan. No blueprint. Just noise. And then gravity shows up. Because wherever the gas was a little bit denser, a little bit more crowded, it pulled harder. And that extra pull dragged in more gas. And that made it even denser. And that pulled in even more. A feedback loop. A runaway collapse. But here is the part that changes everything. When that cloud starts falling inward, all those random nudges, the drifts, the shivers, the shock waves, they do not cancel out perfectly. They never do. Think about it like this. Imagine a stadium full of people all shoving in random directions. 100,000 shoves. Almost all of them cancel out. But not quite. There is always a small lean, a small tilt, a direction that wins by a hair. For a gas cloud collapsing under its own gravity, that small lean is everything. The cloud as a whole starts to rotate. Slowly at first. But it rotates. It has to. And once it starts, it cannot stop. There is nothing out there to stop it. No air. No friction. No brakes. That tiny leftover spin, that little bit of motion that did not cancel, is the Big Bang's fingerprint. The universe's very first memory. The universe remembers. And once you understand that sentence, every spinning thing in this video, every one, is going to make sense. But to see what happens to that memory when gravity keeps squeezing, when the cloud keeps falling inward, I need you to picture something much closer to home. I need you to picture an ice skater. Picture an ice skater, arms stretched wide. She is spinning, slowly, steadily. Not impressive. Now watch what happens when she pulls her arms in close to her chest. She spins faster, much faster. And here is the strange part. Nobody pushed her. Nobody added energy. She did not kick off the ice. She just moved her arms. And the universe answered by spinning her harder. That is a law. It is called conservation of angular momentum. But forget the name for a second. Here is what it actually says, in plain language. Anything that is rotating wants to keep rotating. And when its mass moves closer to the center, it has to spin faster. It has to. Not sometimes. Always. Built into physics. Which means, once the universe is spinning, it cannot forget. Squeeze it smaller, and it spins faster to protect the memory. Crush it down to a point, and it will spin itself nearly to the speed of light before it ever lets go. Remember that wobbling plate in the cafeteria? Feynman's 2-to-1 ratio? Same law. A plate. A galaxy. A skater. One rule. Different volumes. So take that cloud, start collapsing it. Watch what shape it has to take. Because the moment gravity starts squeezing, the cloud stops looking like a cloud. It starts looking like something you have eaten for dinner. The cloud is falling inward under its own gravity. And because it is shrinking, same ice skater law. It spins faster, dramatically faster. What took 1,000,000 years to drift in a lazy circle is now a few thousand years from a violent whirl. But here is the problem gravity has to solve. The cloud is trying to collapse in every direction at once. And the spin, the memory, will not let it. Ever watch someone toss pizza dough? They spin it, and it flattens. Every time. Because rotation throws material outward along the equator, but the poles have nothing holding them up. So top and bottom collapse. The middle stays fat. And you get a disk? A cloud light years across does the exact same thing. Automatic. Inevitable. Disk. Every time. At the center of that disk, material piles up. And piles up. And piles up. Pressure builds. Temperature climbs. 1,000 degrees. 100,000. 1,000,000. 10 million. And at 10 million degrees, hydrogen atoms start slamming into each other hard enough to fuse. 2 hydrogens become helium. A tiny amount of mass gets converted into pure light. A star is born. And that star is spinning. It has to be. It inherited the spin from the cloud it was built from. The same spin that got squeezed faster and faster as gravity pulled it all together. Our sun rotates once every 25 days. It has been spinning like that for 4.5 billion years. Nobody wound it up. Nobody has to. It just remembers. And before we zoom outward, before we follow that spin into planets, moons, and galaxies, I want you to see this one thing with your own eyes. Because Isaac Newton saw it first. 1,689. In a kitchen. With a bucket. Grab anything that holds water. We are doing Newton's experiment. Right now. Pause the video. I mean it. Grab any cup. Fill it with water. Come back. Because for the next 60 seconds, you are going to see the universe's memory with your own eyes. In your own kitchen. Using an experiment Isaac Newton ran 337 years ago. Cambridge. Newton takes a bucket of water. He ties it to a rope. He twists the rope. Hard. Then he lets go. At first, the bucket spins. But the water inside does not. It just sits there. Flat. Still. The bucket's walls drag it along slowly. And then, something strange happens. The water starts climbing the walls. The middle drops. The surface carves itself into a bowl. A perfect curved bowl. And it stays like that. As long as the water keeps spinning. Do this now. Stir your water hard. In a circle. Pull the spoon out. Watch. There it is. The same bowl. In your kitchen. Right now. You just reproduced Isaac Newton's 1,689 experiment in 15 seconds. Now, here is the question Newton asked himself that changed physics forever. How does the water know it is spinning? Because nothing is touching it from the outside. No one is holding up the edges. But the water knows. And it remembers. For as long as the spin survives, the moment the spin dies, the surface goes flat again. Spin is not a description of motion. Spin is physical. Spin leaves a mark. The universe remembers. And now, it is about to start printing that memory into worlds. Because every planet, every moon, every ring you have ever seen is that same curved bowl. Just bigger. Much bigger. Take that curved bowl of water. Now make it 100 million miles wide. And instead of water, use rock, dust, ice, gas. What happens? The same thing. The spin flattens the material into a disk. Dense lumps pull in more material. They grow. They heat up. They round themselves off under their own gravity. And that, right there, is why every planet in our solar system orbits in almost the exact same plane. Not because someone arranged them, because they could not. The disk decided. Now zoom in on a planet. Any of them. Jupiter, Saturn, Uranus. As the planet formed, it kept its own little cloud of leftover gas and dust spinning around it. Same law, same collapse, same disk. Jupiter has 95 known moons. The big ones orbit in a flat plane. Saturn has 146 moons. The big ones, same flat plane. Every giant planet you look at is a tiny copy of the solar system that built it. And then there is Saturn. Those rings are not decoration. Those rings are a disk of ice and dust, held flat by the same law that flattens a galaxy. 280,000 kilometers wide, 20 meters thick. The flattest object in the solar system. A single spinning cloud caught forever in the act of remembering which direction it was turning. Now pause for a second and look at this. Your cup of water. Saturn's rings. Our solar system. A galaxy 13 billion years old. Same pattern. 4 different sizes. One rule. Nested inside each other, all the way down. Physics has a word for this kind of pattern. Fractal. The same shape repeating at every scale. And spin is the universe's fractal fingerprint. Printed on everything. Printed on you. You are spinning right now at 1,000 miles an hour because the Earth you are standing on is spinning. And the Earth is spinning because the cloud that built it was spinning. All the way back to that first Big Bang nudge. So here is the uncomfortable question. If the rule is this clean, if it works from your kitchen cup to a 13 billion year old galaxy, then why, in the name of physics, does 5% of the cosmos break it? Because it does. Somewhere out there, stars are orbiting galaxies at speeds the law says they cannot. And nobody has ever seen what is holding them in. To see the crack in the rule, we have to leave the solar system and go looking for a ghost. Leave the solar system. Keep going. 2.5 million light years. You are at Andromeda, our nearest galaxy neighbor. 1 trillion stars, all spinning around one massive center. By the rule we just learned, stars close to the center should orbit fast. Stars far from the center should orbit slow. That is how every disk works. Inner planets lap outer planets. Inner moons lap outer moons. Inner, outer, fast, slow. Every disk in this universe obeys that rule. Except galaxies. 1970s. Arizona. An astronomer named Vera Rubin is measuring how fast stars orbit inside Andromeda. Nobody thought it was important work. Galaxies obey the rule. Everybody knew that. So Vera measures the inner stars. They are orbiting fast. Expected. Then she measures stars farther out. Still fast. Then she measures the stars at the very edge. The ones that should be crawling. And they are going just as fast as the ones near the center. That is not supposed to happen. That is never supposed to happen. At the speeds Vera was measuring, those outer stars should be flying apart, launching themselves into empty space, leaving the galaxy in ruins. But they were not. The galaxy was holding itself together, somehow, which meant something was there, pulling on those stars, something with enormous gravity, something the telescope could not see. When Vera did the math, the answer came out terrifying. For those stars to orbit that fast, the galaxy had to contain about 5 times more mass than anything a telescope could ever pick up. 5 times more. In every galaxy, in every cluster, everywhere, an invisible scaffold, holding the universe together. And we had never noticed, because it does not glow, does not reflect, does not emit a single photon. It only reveals itself through what it drags. The universe remembers, and the thing it remembers hardest, the thing that spins even when it is invisible, is the part we still cannot see. Spin did not just build the worlds we know. Spin is pointing, right now, in every galaxy, at a ghost we have not caught yet. And if you think a galactic ghost is strange, wait until you see what spin does to a star that collapses into itself. Because there are places where memory gets squeezed so hard, it warps space-time. Take the ice skater law. Push it past every limit you think it has. What do you get? You get a star that ran out of fuel. Its core collapses. Not to a planet, not to a rock. To a ball the size of Manhattan. About 12 miles wide. But with more mass packed inside it than our entire sun. A neutron star. Denser than the nucleus of an atom. And because the skater's arms just got pulled in billions of times tighter, the universe answers by spinning that corpse 716 times. Every second. Right now, 18,000 light years from your couch, there is a dead star the size of a city, spinning 716 times a second. Its surface is moving at nearly a quarter the speed of light. If you somehow landed on it, the spin alone would rip every atom of you apart before gravity finished the job. And that tick you are hearing is the universe remembering, out loud, the direction its parent cloud was rotating in 14 billion years ago. Now push even harder. Collapse that neutron star further. Past every known limit. You get a black hole. And here is the part that breaks your brain. A spinning black hole does not just spin its mass. It spins space-time itself. It drags the fabric of reality around with it, the way a spoon drags honey. Physicists call it frame dragging. Einstein predicted it in 1918. We measured it for real in 2020 around a distant pulsar. The memory of spin is so stubborn, so absolute, that rather than let it go, the universe will bend space and time to keep it alive. And remember, that plate, Cornell, 1946. A bored young physicist watches a cafeteria plate wobble at exactly twice its spin rate. He scribbles the equations. Just for fun, he figures out the 2-to-1 ratio. That equation, the one Feynman wrote on a napkin because a plate was wobbling, is the same equation that describes a neutron star spinning 716 times a second. The same equation that describes space-time being dragged around a black hole. One rule: from a cafeteria plate to the event horizon. That is what he won the Nobel Prize for. But here is the thing Feynman never got to see. Because he died in 1988, 7 years before the Hubble Deep Field, before Vera Rubin's work was fully accepted, before frame dragging was measured. Feynman solved the memory, the mystery, the one his own law pointed at, is still waiting for us. So let us go catch it. Let us follow the spin all the way to the edge of what we know, and see what the universe has not told us yet. So Feynman left us the memory, and Vera Rubin left us the mystery. What have we done with them since? The answer is, we built a spy, a satellite called Gaia, parked 1 million miles from Earth, pointed at the Milky Way, and told to do one thing: measure very precisely how every single visible star is moving. Nearly 2 billion stars, one map, and when you look at the arrows, how fast each star is spinning around the galaxy, you see something you have never seen before. You see the Milky Way's memory, in motion, in full color. Every star in that map is a tiny witness orbiting in a pattern set in place 13 billion years ago. And at the edges, same story Vera Rubin told us. They are going too fast. Again. Still. Everywhere you look. And then, in 2006, we caught something even stranger. A place where 2 galaxy clusters had smashed through each other at 10 million miles per hour. The bullet cluster. When they collided, the visible gas slammed together. Hot, bright, glowing pink in the X-ray telescope. Stuck in the middle, exactly where physics said it should be. But the gravity, the pulling, was somewhere else entirely. Off to the sides. Dragged clean through the collision. Invisible. Untouched. For the first time, we had seen it. Not the stuff itself, but its shadow, its fingerprint, its spin-shaped silhouette moving where the visible universe was not. Now put it together. The flat rotation curves, Rubin. The motion map, Gaia. The separated halos, the bullet cluster. Every one of those measurements uses spin to see what light cannot. And every one of them is telling us the same 3 things. Dark matter is real. You can map it. Dark matter is cold. It moves slow enough to clump. Dark matter is 5 times more. It shapes every galaxy we see. We have not caught the ghost, but we have traced its outline on every wall. And the outline, the entire outline, is made of spin. Which brings us all the way back to you, to the chair you are sitting in, to the cup of water on your desk. Because if every galaxy, every ghost, every invisible scaffold in the cosmos is mapped by spin, then what, exactly, is your spin telling the universe? Because you, right now, in that chair, holding that cup, half paying attention to this video, are spinning, in more ways than one. Inside every cell of your body, right now, tiny motors called ATP synthase are rotating well over 100 times per second, making the energy that is keeping you alive as you watch this. Scale up. Your blood circulating, pumped by a spinning muscle. Your inner ear filled with spinning fluid, which is the only reason you know which way is up. Scale up again. Your body, standing on an Earth spinning you at 1,000 miles an hour. On an Earth orbiting the sun at 67,000 miles an hour. On a sun circling the galaxy at 500,000 miles an hour. On a galaxy falling through the local group riding the cosmic web. Every one of those motions, inside you, around you, through you, is the ice skater's law? The same law Feynman wrote on a napkin. The same law Vera Rubin found broken at the edge of Andromeda. You are not watching the universe spin. You are the universe spinning. You are one of its living fingerprints. A fractal, a layer, a nested memory still being written. The universe remembers. And the universe remembers. Through you. Every atom in your body was forged in a spinning star. Every breath you take moves on an Earth that has been turning for 4.5 billion years. You are not a spectator of cosmic spin. You are its latest, most intricate expression. The plate Feynman watched in 1946 was not just a plate. It was everything. A galaxy. A pulsar. A ghost. A cell. A body. A life. One rule, turning at every scale, including the one under your own skin. He saw it first. And now you have seen it too. But here is what Feynman never got to answer, and what only this generation of physicists, your generation, can. What does the memory want? Where is the ghost pulling us? Because the spin is not finished. Oh, let me show you where it goes next, and what it means for the next 100 years of physics, and for the 24 hours ahead of you. Here is a fact most people do not know. Every single piece of evidence we have for dark matter, every piece, came from measuring something that spins. Vera Rubin in the 1970s. Galaxy rotation. The Bullet Cluster in 2006. Galaxy clusters colliding. Gaia mapping 2 billion orbits right now. 50 years of spin has built the entire case for the ghost. And the next chapter, the one that catches it, is already being built. Right now. While you are watching this. On a mountain in Chile, there is a telescope named after the woman who started it all. The Vera Rubin Observatory. Its camera is the largest digital camera ever built. 3.2 billion pixels. Every 3 nights, it photographs the entire southern sky. Every 3 nights. For 10 years straight. By the time it is done, we will have tracked the motion of 20 billion galaxies. 20 billion spinning witnesses. Each one reporting, through its rotation, exactly where the dark matter is, and is not. A 3-dimensional map of the ghost, drawn by spin alone. And then, in the 2030s, Europe, NASA, and the world's best physicists are launching something that has never existed before. It is called LISA. 3 spacecraft, arranged in a triangle. Each side, 2.5 million kilometers long. Their only job is to listen to space itself ring. When 2 black holes spiral into each other and merge, they spin so violently they send ripples through space-time. Gravitational waves. LISA is the microphone built to catch them. For the first time in human history, we will hear spin. Not see it. Not infer it. Hear it. And already in flight. A mission called Euclid. Launched 2023. Parked 1 million miles away. Watching for one thing. When light passes through dark matter, it bends. Just slightly. The galaxy behind the ghost gets smeared. Stretched. Warped. Euclid is mapping that warping across 1/3 of the entire visible universe. And every smear, every stretch, is a measurement of how the ghost is moving. Spinning. Clumping. Building the skeleton the galaxies grew on. Put those 3 tools together and here is what physicists are expecting. Inside the next 10 to 20 years, we will either catch what dark matter is made of, or we will prove that everything we thought we knew about gravity has been subtly wrong for a century. Either answer rewrites the textbook. Either answer is bigger than the Higgs boson. Either answer changes what you teach your kids about what the universe is made of. And you, right now, are the first generation of adults who will live through that answer. Feynman did not get to. Vera Rubin did not get to. You will. So here is what to do with that. Because there is one piece of Feynman, not a theorem, not a formula, that you can take with you into tomorrow morning. And it is the only piece of him that mattered. Here is a secret about Feynman. The Nobel, the physics, the equations, those were just outputs. They were not the engine. The engine was one habit, and you can have it. Starting tonight, Feynman paid attention to the things everyone else dismissed. A wobbling plate, a dripping faucet, ants walking in a line. He would ask, why? Not the grown-up, polite version. The kid version. The version that does not stop until there is an answer. So here are 3 things you are going to notice in the next 24 hours. On purpose. 1. Tomorrow morning, stir your coffee or your tea. Hard. Pull the spoon out. And watch the bowl form. The exact bowl Newton saw in 1689. The exact bowl that shapes every planet in our solar system. You just made one. 15 seconds. Kitchen. 2. When you wash your hands tonight, stop for 3 seconds. Watch the water leave the sink. That tiny vortex tightening as the water shrinks toward the drain, that is the ice skater's law, happening in your bathroom. The law that spun the sun into existence. The law that winds a neutron star to over 700 times per second. Same law. Same memory. Different volumes. 3. Before you sleep, step outside. Look up. If you can see the moon, that moon is falling toward Earth right now at a little over 2,000 miles an hour. It has been for 4.5 billion years. It just keeps missing. And you are standing on an Earth spinning you at 1,000 miles an hour, under a sun carrying you 500,000 miles an hour, inside a galaxy riding the cosmic web at 1,000,000 more. All while you brush your teeth. That is the Feynman habit. That is the whole thing. Stop once a day. Look at something moving. Ask, what is it remembering? Because the universe remembers. And tomorrow morning, if you are paying attention, you will see it remember. In a cup, in a sink, in a sky. Ooh. So here is one last thing to leave you with. Because there is something about this video, and about the ghost we are still hunting, that I promised you at the very beginning. And I want to keep that promise before we close. So here is the whole story in one breath. A young Feynman watched a plate wobble in a cafeteria and found the rule. Vera Rubin watched stars at the edge of Andromeda and found the mystery. And right now, 3 instruments on 3 continents are closing in on the ghost that Rule was pointing at. 1 plate. 1 galaxy. 1 ghost. 1 rule, turning from your coffee cup to the edge of the cosmic web. And the next time something in your day spins, your coffee, your car wheel, the water in your drain, the moon above your street, you will know that is not a coincidence. That is the universe, 4.5 billion years deep, still remembering which way it started. And now you are watching it. If this gave you a new way to look at something simple, do 3 things for me. hit subscribe, because the next 35 minutes you spend on this channel will give you another one. Tap like. It tells YouTube a grown-up video with no shortcuts can still find its people. And in the comments, tell me the first spinning thing you noticed after this video ended. One object. One sentence. That is how I will know you actually saw it. Next video. The final question Feynman asked about time. One nobody has fully answered yet. I will see you there. Huh.